All right, so in this set of notes, we're talking about the vector product, which is another definition or type of multiplication between vectors. So as you might guess, the result of this one is going to be a vector. It's why we call it the vector product, not the scalar product. In class, I'm going to show you what the vector product means in terms of 3D geometry, but right now we're going to talk about how to find it mathematically. So you can see here, and also in your formula booklet, that we have this definition that the vector product is magnitude V, magnitude theta, magnitude V, magnitude W, sine theta times n, where theta is the angle between and n is the unit normal. So unit, length 1, normal means perpendicular. So that's really what we're finding with the cross product. We're finding a vector that's perpendicular to the other two. So I could set this up and try and solve for it mathematically using dot product rules, but I'm just going to show you the way that we calculate it mathematically. So I'm going to start with just two random vectors. So let's let vector v be equal to 1, 4, negative 2. And let's let vector w be 3, negative 1, 1. So the cross product, v cross w, is going to result in a new vector that is perpendicular to both of these. So I'm going to call it vector n. So n hat would have a length of 1, but this is just a vector n perpendicular to both of them. So the way that I calculate this, I've got two different ways to do it. One way is to set up a matrix. So I'm just going to organize these by writing down ijk. So remember, those are my base unit vectors in x, y, z. And then I'm going to write each of my components under it. 1, 4, negative 2, 3, negative 1, 1. And I'm going to find the determinant of this matrix. So we haven't found determinants of matrices. In fact, we haven't even really talked about a matrix. So a matrix is just an array. In this case, I've got a 3 by 3 sort of grid. What I do to calculate this value is I come off to my right here and I start with I. So I'm going to write I. And then I'm going to multiply I by ignoring everything in the I column and row. So now I'm just looking at these numbers. And what I'm going to do is find the difference of the diagonal products. So I'm going to take the difference of 4 and 2. So I just did 4 times 1 minus negative 1 times negative 2. And that's my I. Now I'm going to do minus j. So I'm going to alternate positive, negative, positive. So I'm going to have plus k down here. Again, I'm going to ignore j's row and column. So I'm going to move this column line to be over here. So I'm ignoring j's row and column. And I'm going to do the same thing. I'm going to subtract the product of diagonals. So 1 minus negative 6. 1 minus negative 6. I'm going to come and do that with k as well. So again, ignore row and column that k is in. So I'm going to erase this one. And now I'm going to do negative 1 minus 12. So I'm going to get a new vector, and that vector, I've got 4 minus 2 is 2, so 2i. 1 plus 6 is 7, so minus 7j. Negative 1 minus 12, negative 13k. So the result of v cross w is going to be 2, negative 7, negative 13. So let's test if this is perpendicular to both of these. So I'm going to do n dot v. Oops. So that's going to be 2, -7, -13, dotted with 1, 4, -2. If they're perpendicular, I should get 0. So 2 minus 28 plus 26, that does equal 0. And I can test n dot w. So 2 times 3 is going to be 6. -7 times -1 is +7. -13 times 1 is -13, also equals 0. So n is perpendicular to v, and n is perpendicular to w. If you look in your formula booklet, it's going to give you a mathematical formula for calculating this, and I'll look at that in the next video.